Hello my dear champions, welcome to Deeksha Karnataka YouTube channel, and it's time for me now to discuss the chapters atoms as well as nuclei. So both chapters will be covered in this single video, and I am going to discuss all the important questions from these two chapters, including 15 MCQs each from these two chapters. So 30 MCQs and lots of questions that I am going to discuss in this chapter. So first we will start with the chapter atoms. So atoms is the first chapter. Now let us look into the blueprint of the chapter atoms. So here we are going to discuss one marker question. We are going to get one marker question and one 2 marker question. So there will be no fill in the blanks coming from this chapter, and the weightage of this chapter is only 3, but we will try to finish it as quickly as possible. How many questions we are going to discuss? We are going to discuss 15 questions of 1 marker and 5 questions of 2 marker. So let us start with the MCQs. The total energy of an electron revolving in nth orbit of hydrogen atom is least for. So total energy of hydrogen, total energy is least means it maximum negative. So it will be negative. So total energy for ground state. Total energy of any state, actually let us start with total energy of any state is minus 13.6 divided by n square. So if the n value is smaller, then we will get the least value, because this is a negative sign. There is a negative sign, means higher the negative value, smaller is actual value. That means it is least for n equals to 1. That's why it is the most stable orbit. Lower the energy, it is more stable. Right. Next question, the minimum energy required to free the electron from the ground state of hydrogen atom is. Obviously the total energy is minus 13.6 electron volt, so you will need at least that much energy to free up an electron. Okay, so 13.6 electron volt energy you will need to free up one electron from hydrogen's ground state. Next, let K be the kinetic energy, U be the potential energy, and E be the total energy of the electron revolving around the nucleus in hydrogen atom. Then which of the following is correct? K greater than 0, U greater than 0, E greater than 0. Let us understand about the energies. So total energy we already realized, total energy is negative. What about kinetic energy? Kinetic energy is given by, kinetic energy for any object is given by half mv squared. This is true for electrons as well. Now mass cannot be negative. Even if velocity is negative, square of velocity cannot be negative. That means half mv square is always positive. So that's why we say that kinetic energy is always positive. Right? Now in case of atomic physics, kinetic energy will still be positive. Okay, total energy is negative, potential energy will also be negative. That's why electron is orbiting around the nucleus. So potential energy and total energy are negative, whereas kinetic energy will be positive. So if you read the options, kinetic energy positive, potential energy is negative, total energy is also negative. Right? So option B is correct. The impact parameter is minimum in alpha particle scattering experiment for the scattering angle of. Interesting question. What is impact parameter? Impact parameter is the perpendicular distance between the trajectory and the center of the nuclei. So if the trajectory is along this, then this is called impact parameter. This distance is called impact parameter B. Okay, now if it is said that the for alpha particle scattering, the impact parameter is minimum. Impact parameter is minimum means it is going straight towards the nucleus. It is going straight towards the nucleus. Then impact parameter is 0, and it will come back straight along the path. It meant it will hit the nucleus, or it will try to hit the nucleus. Okay, it will go to the distance of minimum closest approach, distance of closest approach, and then it will come back. Right? So that means the deflection will be 180 degrees. So when the deflection is 180 degrees, the impact parameter is minimum. Okay, don't fall into the prey. Minimum means 0 degree. No. Next, Bohr's atomic model cannot explain spectral lines, stability of atoms, fine structure of spectral line, all of the above. So Bohr's atomic model can explain spectral lines. It can also explain the stability of atoms. Only thing it cannot explain is the fine structure. Okay, fine structure means the splitting of electric spectrum under the effect of external fields. So that's why Bohr model is not complete. It is the first correct step towards finding the correct model, but it was not complete because it was not able to explain the spectral lines, fine spectral lines. The ratio of radii of first 3 Bohr orbit. So ratio of radii of first 3 Bohr orbit R1 is to R2 is to R3. Okay, so this will be equals to R1 is to 2 square R1 is to 3 square R1. Okay, Bohr's orbit for nth orbit it is given by n square R1. Okay, so this is the first ground state orbit. So from here you can say that this must be 1 is to 4 is to 9. So correct answer is 1 is to 4 is to 9. Option C is correct. Now let's move on. At the distance of closest approach for alpha particle with gold nucleus, both kinetic and potential energy are equal. Okay, so distance of closest approach of alpha particle with gold nucleus, both kinetic energy and potential energy are equal. Entire kinetic energy is converted into potential energy. That is the correct answer. Kinetic energy is not equal to potential energy. The initial kinetic energy is exactly equals to the potential energy. So entire kinetic energy is converted into potential energy. They are not balanced by each other. Okay, so entire kinetic energy is converted into potential energy and it momentarily stops at the distance of closest approach. So that's why option B is correct, not option A. Don't fall for the trap. Don't answer option A. Rutherford's nuclear model of atom fails to explain large angle scattering of alpha particle, charge distribution of an atom, energy of electrons revolving around the nucleus, origin of line spectra of hydrogen atom. Actually it is many of the points, but main is origin of the line spectrum of hydrogen. It cannot explain. Okay, energy of electrons can be explained. Charge distribution partly can be explained. Large angle scattering of alpha particle, obviously it was assumed that the center is obviously at the center, it is located at the center. That's how it was came to be. So large angle scattering, based on large angle alpha ray scattering, Rutherford gave its nuclear model. So definitely these three can be explained. But spectral line, why we observe spectral line, that was not clear. So that's why spectral line of hydrogen was not been able to explain using Rutherford's nuclear model. The scientist who is credited with the discovery of nucleus, it's Rutherford. Okay, Rutherford is the person who was credited with the discovery of nucleus. When white light passes through a gas and we analyze the transmitted light using a spectrometer, we find some dark lines in the spectrum. These dark lines are called emission spectrum, absorption spectrum, missing line, dark band. They are called absorption spectrum. So you have a gas, okay, and light is passing through this gas, and when you observe this gas, suppose there are 4 lines, but when you observe it, you find only 2 lines and 2 of them are missing. Okay, so this is called absorption spectrum. Like emission spectrum, same thing is possible for absorption spectrum as well. So what is the meaning of absorption spectrum? For example, the light which is coming from sun, okay, when it is passing through our atmosphere, some of the emitted lines are absorbed, some of the emitted frequencies are absorbed, right? For example, all the UV rays are absorbed by our ozone layer. So that's why we do not have that ozone UV rays present in our light, right? Similarly, some other dangerous rays, some other infrared rays can also be absorbed during our atmospheric gases at its transit through the atmospheric gases. So those are called the absorption spectrum. That means the gases absorb those radiations and then they give you the output. That's why it is called absorption spectrum. What is the meaning of emission spectrum? When you excite a gas, okay, you heating up a gas, or you are sending some electrical energy through a gas, then that gas automatically emits some radiation. That is called emission spectrum. So emission happens when the gas is excited, absorption happens when the gas is at neutral state and some ray of light is passing through this. Next, the lowest state of the atom called lower orbit, ground state, earth state, none of the above. What about call it Empire State Building? Right? No. It is called ground state, not Empire State from where King Kong jumped. If you remember the movie, King Kong jumped from a top of a building. Empire State, but not Empire State, it is ground state. The radius of nth Bohr orbit is proportional to n square. The total energy of the electron orbiting a hydrogen nucleus is negative. This implies the fact that the electron is free to move, electron repels the nucleus, electron is bound to the nucleus, all of the above. So when we say that the energy of electron is negative, that means electron has to pay back the money, okay, then only it can leave. So electron is not free to leave, it can move only in its orbit. So basically you have taken loan from some person, some of your friend, and you cannot leave him. If you leave, then he will kill you, something like that, some imaginary situation. So that's what is happening over here. Electron has taken some loan from the nucleus, and that is minus 13.6 electron volt. So if he wants to leave the nucleus, it has to pay back that energy, and then only it can leave. So if someone else gives him that minus 13.6 EV, that is positive 13.6 EV, then it will repay its debt, and it can move to the it can move freely, right? So electron is bound to the nucleus. Electron is bound to the nucleus. The total energy of electron orbiting hydrogen is negative. That means electron is bound to the nucleus. So it has some money to pay back. So once he is paying back that money, he can leave. Otherwise, throughout his lifetime, it will keep on orbiting the nucleus. Next, in a Bohr atom, an electron emits energy only when it moves from ground state to excited state. Okay, in Bohr atom, an electron emits energy when it is moving from excited state to ground state. So electron emits energy when it is moving from excited state to ground state. From ground state to excited state, it will absorb energy, okay, and it will give out energy when it is jumping from excited state to ground state. Okay, so option B is correct. The energy of an electron at the ground state of hydrogen atom is minus 13.6 eV. Okay, the energy means total energy. Okay, total energy of electron at the ground state of the hydrogen atom is minus 13.6 eV. Write any two postulates of Bohr's atomic model. Now, Bohr's atomic model, postulates of Bohr's atomic model, one of the most important questions. Previously, it can come as a 3 marker, but from this chapter, this year, we are only expecting 2 marker questions. So, they will change the question like that. So, there are 3 postulates. So, they will say write any 2 postulates, okay. So, an electron cannot move round the nucleus in all orbits. It can only move in certain discrete, discontinuous orbits, okay. So, there is no link between 2 orbits. They are discontinuous and obviously discrete. Discrete means they are separated from each other. The permitted orbits are those in which the angular momentum of the electron is an integral multiple of h by 2 pi, that is mvr equals to mvnrn equals to nh by 2 pi. When the electron moves in these orbits, energy is not given out. Energy is given out only when an electron from a higher energy state jumps to a lower energy state. The difference in the energies is permitted in the form of E1 minus E2 equals to h nu. Okay, Clear? So any two you can write for this question. So this year there will be not, you don't need to remember all three, you can study any two and you should still get the marks. Write two limitations of Bohr's atom model. Now we have to write down the limitations. Previously was postulates, now it is the limitations. Bohr's model is applicable to hydrogenic atoms. It cannot be extended even to mere 2 electron atoms such as helium. While the Bohr's model correctly predicts the frequencies of the light emitted by the hydrogenic atoms, the model is unable to explain the relative intensities of the frequencies of the spectrum. The model does not explain the fine structure and splitting of spectral lines observed under the magnetic field Zeeman effect or electric field Stark effect. Okay, so Bohr's atomic model cannot explain Zeeman effect and Stark effect. Okay, also it cannot be extended to the more than one electron system, for example helium, lithium, and also it is unable to explain the relative intensities. According to Bohr's model, all lines should be equally bright, but when we observe the spectrum, we see some of them are more bright than some other one may be slightly little bright. So that's why relative intensities cannot be explained using Bohr's model. Define impact parameter. What is the angle of scattering for minimum impact parameter? So impact parameter B is defined as it is the perpendicular distance between the initial direction line of motion of an incident particle and the center of the target nucleus when the particle is far away from the nucleus. Suppose we have a nucleus and an alpha particle which is moving along this line. This is the center of the nucleus. So the impact parameter is defined as the, if you continue on this path, okay, the distance between the line of the path and the center of the nucleus is called impact parameter, and that is denoted by symbol B. Okay, angle of scattering for minimum impact parameter. So minimum impact parameter corresponds to a head-on collision, that is impact parameter is 0. In this case, the particle is scattered through an angle of 180 degrees. So we have seen one MCQ as well as a long answer question from this concept, and this question is taken from your latest model paper. The radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 to the power of minus 11 meter. Determine the radius of the n equals to 2 orbit. This is again your model question paper problem. So we know that Rn equals to n square R1. Okay, so n square is 2 square into R1 is this value, 5.3 into 10 to the power of minus 11. So 4 into 5.3 into 10 to the power of minus 11. So it will be 21.2 into 10 to the power of minus 11 meter. Very simple, easy question. Okay, Rn equals to n square R1. R1 is given in this problem, so you just need to put that value and calculate. Okay, 2 marker question. If you just add it, do it, you can get the 2 marks. Mention 2 drawbacks of Rutherford's atomic model. So Rutherford's atomic model fails to explain stability of atom, no explanation for atomic spectra, does not address the electron arrangement. Okay, so these are the main 3 drawbacks. Any 2 you can remember and answer. Now next chapter is nuclei. So nuclei again will be checking the blueprint. So in the blueprint there will be one 1 marker question and 1 3 marker question. So total marks allotted for this chapter is 4. Okay, and in this lecture we are going to discuss 15 very important MCQs and 5 as usual 3 marker question. So let us continue. Among the following, which set of nuclei are isotopes? Isotope means they have same element and a different number of atomic mass. So same element means their neutron number should be same, symbol should be same. So U 23592, U 23592. I think there should be some mistake. This should be 238. Okay, so these two should be your isotopes. Okay, now next, the radioactive decay in which very high energy photons are emitted is called. So radioactive decay in which a very high energy photons are emitted is called gamma decay. Alpha decay, beta decay are not high energy photons, they are basically particles. That's why they are fast moving particles but not high energy photons. Photon means only gamma decay where gamma rays are emitted. Next, the ratio of nuclear densities of aluminium 22713 and 64 copper 29 is. So nuclear densities of elements are constant, okay, except some very few lighter and very high atomic mass objects. Ratio of nuclear densities is constant, so it will be 1:1. Ratio is 1:1. You do not need to take square root or anything. Radius, okay, you can calculate radius, but they ask you about nuclear densities. Nuclear densities means it must be constant. So whatever is the nuclear density for aluminium, same should be for copper as well. The nuclear force is attractive for distance equals to 0.5 fermion. Attractive for distances less than 0.8 fermion, repulsive for distance 0.8 fermion, repulsive for distance less than 0.8 fermion. So here remember that nuclear force is repulsive up to 0.8 fermions and it becomes attractive from 0.8 towards higher values. Okay, 0.8 to 2.2 actually is the range where nuclear force is active. Beyond to 2.2 nuclear force becomes 0. So attractive for distance r equals to 0.5, definitely not correct because this distance is less than 0.8 fermion. So definitely at this range it is repulsive. Attractive for less than 8, again in this range it is repulsive. Repulsive for r greater than 0.8, again this is wrong because in this range it is attractive. So repulsive for distance less than 0.8 is only correct answer. So this is the correct answer. This is one of the previous year questions came from this chapter. The nuclear radius of the order of, the nuclear radius is of the order of 10 to the power of around, nuclear radius is 10 to the power of 14 times more than that of the atomic radius. So you can take consider this to be of the order of 10 to the power of minus 10 meters. Minus 15 is too small. Okay, it is of the order of 10 to the power of minus 10 meters, slightly few hundred Fermis. Okay, so here you can see this is few hundred Fermis. This distance is much smaller than 1 Fermi. In that case nuclear cannot exist because smaller than 1 Fermi means the force will always be repulsive. Okay, Fermi means 1 Fermi means 10 to the power of minus 12 meter. Okay, nuclear radius is greater than this value, and that is here only one greater than this value is 10 to the power of minus 10. So it is approximately 10 to the power of minus 10 meter. Chadwick discovered photon, proton, electron or neutron. Chadwick discovered neutron. Okay, remember that photon is mostly associated with Albert Einstein, proton is associated with Rutherford, electron is associated with J.J. Thomson. Okay, so remember that this is Einstein, this is proton is Rutherford, and electron is J.J. Thomson. Okay, and neutron is discovered by Chadwick. Okay, so in one table all the discoverers are mentioned. Next, the ratio of nuclear mass to the nuclear volume is called nuclear mass, nuclear volume, nuclear charge, nuclear density. Easy question. Mass by density, mass by volume is always density. In case of nuclear mass by nuclear volume, it will be nuclear density, and normally it is a constant quantity. 1/12th mass of carbon 12 atom is 1 atomic mass unit, or 1 U or 1 AMU. Okay, Neutron was discovered by, okay, same question, James Chadwick, okay, repeated question, but they have changed the order. So neutron was discovered by James Chadwick. Nuclei with same atomic number are called, same atomic number means they have the same number of protons, that means they are called isotopes. Okay, same mass number are called isobars. Okay, isobar means same mass number, and isotones are same neutron number. Isomer is from organic chemistry. Chemistry ma'am will teach you more about isomers, okay, not me. Next, the equivalent energy of the mass defect is atomic energy, nuclear binding energy, nuclear fission, nuclear fusion. So the equivalent energy of the mass defect is called nuclear binding energy. So the equivalent energy of mass defect is nuclear binding energy, not fission, not atomic energy, okay, not fusion, it is the nuclear binding energy. Next, nuclear fission is a process where two light nuclei combine to produce a heavy nucleus, two heavy nuclei combine to produce even heavier nucleus. The options are making me laugh. One heavy nucleus breaks into one or more stable nuclei, so that is the correct answer. Fission is process where it breaks down, okay, one heavy nucleus when it breaks down into more stable and lighter nuclei, that is called fission. Fusion is when two are fusing together. An alpha particle is hydrogen nucleus, helium nucleus, hydrogen atom, helium atom. Alpha particle is doubly positive helium, that is basically the nucleus of helium. The nuclear force between neutron-neutron is more than between proton-neutron. Proton-neutron is more than that between neutron-neutron. Neutron-neutron and proton-neutron are same. So option C is correct. Okay, this will be proton. So nuclear force between neutron-neutron and proton-neutron are same. The energy equivalent to a substance of mass 1 gram is. So let's do this calculation. So energy equivalence means we have to use our age-old formula, E equals to mc square, and mass here given as 1 grams. 1 gram means 1 into 10 to the power of minus 3 kilograms, and C is 3 into 10 to the power of 8 whole square. So it will be 10 to the power of minus 3 into 9 into 10 to the power of 16. So it will be 9 into 10 to the power of 13 joules. So the corresponding energy is 9 into 10 to the power of 13 joules. Now let us move on to 3 marker question. First question, differentiate between nuclear fission and nuclear fusion. Again, this is a new question, came in your model paper. And so nuclear fission is a heavy nucleus splits into two lighter nuclei. Nuclear fusion is when two light nuclei. So in fusion you need to have minimum 2 atoms. Okay, so two light nuclei combine to form a heavier nucleus. Occurs in heavy elements like uranium-235, plutonium-239. Occurs in lighter elements like hydrogen isotopes H2H3. Releases moderate amount of energy, releases very large amount of energy, much greater than fission. Okay, reaction can be controlled in a nuclear reactor, and reaction is extremely volatile, and it is very difficult to control in our environment. Okay, that's why cold fusion or fusion which can be controlled, if you can determine a machine or you can design a machine which can withstand nuclear fusion, then definitely you will get a Nobel Prize. Okay, this is not achieved by any human till date, because the initial temperature required to start nuclear fusion is equivalent to the temperature of sun. You can create that using atomic energy. So you have to first conduct a fission. Okay, that is, you have to blast a nuclear bomb to generate enough energy to blast a hydrogen bomb. Okay, hydrogen bomb, that is one of the form of bombs where nuclear fusion takes place. Okay, so nuclear fission has to be done first to do a nuclear fusion. So that's why it is very, very tricky and difficult to achieve, and the energy that will be released obviously will be enormous. Next is define binding energy and mass defect. Write the relationship between them. The difference in mass of nucleus and its constituents delta m is called the mass defect. So delta m equals to zmp plus a minus zmn minus m. The energy required to separate a nucleus into its nucleons is called nuclear binding energy, EB, that is EB equals to delta m c square, right? So if you calculate delta m, you can calculate the binding energy as well. Next, write three properties or three characteristics, three types or three characteristics of nuclear force. So the nuclear force is much stronger than the Coulomb force acting between charges or the gravitational forces between the masses. You can write that nuclear force is the strongest force. The nuclear force between two nucleons falls rapidly to zero as their distance is more than a few femtometers, or nuclear force is a short range force. Okay, and if you can mention, if you are writing short range, you have to explain it. Okay, the nuclear force between neutron-neutron, proton-neutron and proton-proton is approximately same. That is, the nuclear force is independent of electrical charge. Next, calculate. So from this chapter sometimes we can get some binding energy related small numerical problems. So we will be solving two numerical problems. That's it. Calculate the binding energy of an alpha particle in mega electron volt from the following data. Mass of alpha particle is 4.00260 U. Mass of one neutron is 1.008662. Mass of proton is 1.007825. Now to exactly calculate the value, you have to use a calculator. Okay, I will not do the exact mathematics. I will just tell you how to calculate it. You have to do the mathematics yourself and tell me the answer in the comment section below. Okay, so what is the calculation? Calculation is simple, that mass of alpha particle is 4.00260. So we have to calculate the mass defect. Delta m equals to mass of neutron. Mass of neutron is mn into number of neutron plus mass of proton into number of protons minus the actual mass of the alpha particle. Okay, now how many neutrons are there in an alpha particle? In an alpha particle, total nucleons are 4. Out of that, 2 are protons and remaining 2 are neutrons. So it will be 1.00866 into 2 plus 1.07825 into 2. This is the rest mass of alpha particle, but when they form the alpha particle itself, the mass reduced to this value, which is 4.00260. Okay, so you have to calculate the binding energy in terms of MeV. So this way you will get the binding energy in U. Okay, and it will be 2.086 into 2 is 17.86 means 160, 172 plus 12, 173. So this should be the somewhat closer to the value. Okay, this calculation you have to do on your own. I am doing some approximation method. So 2.015 approximately 2.15. Okay, 2.17 and 2.15. Again, as I mentioned, I am not doing exact calculation. You have to calculate it exactly using a simple calculator. 4.00260. If you add it, you will get 4.032 minus 4.0026. So it will be approximately 0.0294. Approximately, this will be the change in binding energy. This is the this mass is called the mass defect. So corresponding binding energy is given by delta m c square, but we will not use this method. What we will be using, we will convert this directly by delta m into 931.5 MeV by c square. So this will be 0.0294 into 931.5 MeV. Okay, so this is the way to convert directly, right, from mass defect to binding energy. Mass defect to binding energy, you have to multiply with 931.5. okay, this is an easy conversion. So this will be coming out to be, I think, 1.8 about. Okay, you can calculate this exact value. As I mentioned, I will be not solving that. 1 2 3 1 2 2.9 into 9. Okay, I think it will be coming out around 18. You can check that out and you can calculate, tell me the exact value. Okay, mention it. I will not be solving this value. This is up to you. Find the binding energy of an alpha particle from the following data. Almost same data problem, only thing is that the values are different. So this is a homework for all of you. Okay, this is a homework for all of you. Solve it. Same question, the data is slightly different, so mass of the nucleus is different, rest mass of the proton is also slightly different, rest mass of neutron is slightly different. Okay, there are few problems on from which the questions can come. So this is a homework. So every problem will be similar. Okay, so either it will be asked as a nitrogen or an oxygen or alpha particle. Okay, only you have to remember, the only formula that you need to use is mass defect is number of neutrons into mass of neutron plus number of protons into mass of protons minus the total mass, and at the end the binding energy is given by delta m into 931.5. and if they ask you binding energy per nucleon, then what you have to do, you have to divide it with the total number of nucleons. For example, for alpha particle the nucleon number is 4. Okay, for nitrogen 14 the number of nucleon is 14. Okay, so remember that total atomic mass or atomic number, you have to divide it, then you will get the binding energy per nucleon. Okay, so this is a homework. Solve it and let me know the answer. So if you like this video, don't forget to give it a like, and also don't forget to share with your friends and subscribe to our channel if you have not yet subscribed. We are going to bring a lot of content for all the PU students. I will be back with a new video. Till then, bye.